Okay, so this is set 3 that's up here, since we were just talking about it. I've got it so big that you can't really see the equations over here, but you can see what the constants are right here in the front. So, real quick, because you can't tell them here because it's all black and white, which graph is which? This one right here is the 2e to the x. Then this one right here would be the 0.5 e to the x. And this one over here is the 3 e to the x. I knew that without even plugging them in. Why? How did I know that?
Because you're a math teacher.
Oh, and because we've been doing transformations since the beginning of the year. What does a fraction do to something?
Makes it
Makes my brain hurt.
more
Makes it
gradual.
It makes it wider. Why? If it was a quadratic, what would it do to it?
Go upward.
It would vertically.
It vertically compresses it. It pushes it down like this. Fractions get vertically compressed. Nothing's changed. The rules are all still the same. This is a vertical compression. It's been getting closer to the x-axis because it's getting pushed on from the top. What does a number bigger than 1 do? Yeah, it vertically stretches and gets steeper, which is how I knew it was this one. It's getting closer to the y-axis. It's getting pulled from the top and getting steeper. These are just transformations, just like we've done since the beginning. I'm glad you asked that. So I'll get to that in just a second. If you'll go ahead and flip to the next page where it has the blanks for us to fill in, let's go ahead and fill in those blanks. And we will talk about the horizontal because it's not on here. No, not necessarily. I'm not saying that. But transformations are transformations. It really doesn't matter what the function is. So real quick, let's just clarify stuff we already know. If the a value is in front of the function, just like this, we just said what it does. It's a vertical stretch or compression. If a is greater than 1, which one is it?
It's a stretch.
It's a vertical stretch. And it still gets closer to the y-axis, but it looks a little bit different because when it's a quadratic, you can tell both sides are getting closer to the y-axis. Now that it's exponential, it looks different. So you have to just look at the one piece that's up there. It's getting closer to the y-axis. If it is between 0 and 1, meaning that it's a fraction or a decimal, what happens? It's a compression, and it's getting closer to the x-axis. Just like the one we were just looking at. It was 0.5 or a half, and it was getting like it was pushed down. And then they always put this one here. I prefer to think of it as separate, but if a is less than 0, that means it's negative. And what does that do?
Reflex.
Yeah, it flips it over. Reflects over the x-axis. If you'll think of those two things separately, it makes more sense because you could have negative 1/2 x to the e. And that means it's flipped and compressed. So if you'll think of it as, is it negative, then is it a fraction or a whole number? It makes it a little easier. All right, so right in the middle, these two things we already talked about. We talked about those on Friday with Are You Able with the table, and then we talked about them a little bit again yesterday. The b value is the base that the exponent's attached to. And it is specific to this function, to exponential functions. If the b value, think back to when you're able with the table. If the b value was bigger than 1, what was happening on my table? It was increasing, thank you. Now if it's increasing on a table, what does that look like on a graph?
Horizontal compression.
It looks like this, right? Rising to the right. If it's linear, it'll be going straight up. So that's all that this means. If b is greater than 1, the graph is rising to the right. We talked about this part also on that Friday. If it's between 0 and 1, it's falling to the right. It's decreasing as you go down the table. So it's falling right. Now remember what we talked about, and we're going to talk about it a little bit more at the end of this little packet. There are no negative bases. They don't work for this particular function, and we'll talk about it a little bit more in a minute. So your base is always going to be either a decimal or a fraction less than 1 or a number greater than 1, because we're not going to have any negative bases. All right, then we have the plus k here at the end. What does plus k do? What has it done since the beginning?
Y-intercept.
It's the y-intercept. It moves stuff up and down, right? So if it's greater than 0, what's it do?
It's above,
It's, yeah,
Yep,
positive on
right. Shifts up, right? If it's less than 1,
it,
shifts down. Now this last little thing they've thrown in here, this is kind of a thing specific to this function. It's not really a transformation, but it happens because of your transformation. This is just them telling you whatever your k value is, wherever you've been shifted, that's your asymptote. So on the parent function, what's my asymptote? On the original parent function, y equals a times b to the x power. Elisa's right, it's 0. So if I add something on the end, that addition on the end, that is what my asymptote moves to. Or if I subtract something, my asymptote moves down. Now, Travis asked, what about horizontal shifting left and right? That still happens with this function, so I'm really not sure why they didn't put it on this worksheet. It doesn't happen a lot with exponential functions, but it does happen. So how would you know that it's supposed to be moving left or right? How do you always know? What indicates to your mind? Or, yes, parentheses. If it was quadratic, we'd put parentheses. If it was a square root function, what would we do? A fraction bar would do it. Just put it inside the square root symbol. It has to be grouped with x, right? If it's grouped, no matter how it's grouped, parentheses, square root sign, fraction bar. In this case, how do you think they group it?
X, at the little x from right there, x.
Yeah, they just put it up here. So it would be, and usually the letter that we use for that is h. So it would be like this, x minus h. And that would tell you if it's shifting. If it's minus, which way does it go? To the right. And if it's negative, it goes. If it's positive, it goes left. So, and they do happen. I don't know why they didn't get it on this worksheet, but they do happen. So it can still shift right and left. Okay, so now we're going to look at these 3 things on the bottom. And based on what we just went over, we just reviewed as far as transformations go, we want to figure out whether our A value is positive or negative, whether our B value is less than or greater than 1, and whether our K value is less than, greater than 0, or equal to 0. So if you look at this function, is A less than 0 or greater than 0? What do you think?
Less than 0.
Less than 0. Why?
Wait.
Yeah, because it's reflected. Because it's flipped over. It's down here. So it's less than 0. Now, this next one, don't let this throw you off, because it's been reflected. So now, is my B value less than 1 or greater than 1?
Would it be great?
It's greater than 1. Now, I totally understand why you'd say less than 1, because it's falling right. But the reason it's falling right is because it's been reflected. If I pick it back up and put it back up here where it's supposed to be, it's actually rising to the right. So B is greater than 1. Yes?
As far as, like, say it wasn't reflected and it was going down, how would that look? Would you start from, say, like that?
Like this.
And go down? Okay.
Okay, what about our K value? Is your K value less than 0, greater than 0, or equal to 0?
Equal.
Equal to 0. You can see your asymptote right here as it's getting closer and closer to 0. Now the one in the middle. Is your A value less than 0 or greater than 0?
Greater.
Greater, because it has not been reflected. Is your B value less than 1 or greater than 1? Greater, because it's increasing. And is your K value less than 0, greater than 0, equal to 0?
Greater than.
Greater than 0. So this has been shifted up. My asymptote's up higher now. Last one. Is your A value less than 0 or greater than 0? Has it been reflected?
No.
No. So it's greater than 0. Is your B value less than 1 or greater than 1?
Less than.
Less than 1. This is a decay problem. And is K less than 0, greater than 0, or equal? Less than, because now my asymptote is down below the x-axis. So This one's less than. All right, if you'll flip to the top of the next page and plug in y1, 2, 3, and 4 all at the same time in your calculator and fill in the table.